Okay, so get this. There's this new research paper, and it's really blowing my mind, honestly. It's about long COVID, which we know is still a huge mystery for so many people.
Absolutely.
Like, it can have such a huge impact on people's lives.
Yeah.
Lingering symptoms, different for everyone. But this study, it actually followed people with long COVID for 2 years.
2 years. Wow. That's incredible.
Wait, can you believe that? 2 whole years. And they were looking at their immune systems the whole time.
That is a long time for a study like this.
It really is. And it was published in PNAS. That's the Proceedings of the National Academy of Sciences. So you know it's legit.
Oh, for sure.
This is like cutting edge stuff here. But anyway, what really blew me away was that they were looking at T cells.
Okay. Yeah.
Which are like, think of them as the detectives of your immune system.
Yeah, that's a great way to put it. So those T cells, they're crucial for long-term immunity because they provide that like targeted defense, right? Against viruses your body has already encountered.
You remember.
They remember.
It's like having your own little personal army ready to fight.
Exactly.
That's why this is so important for long COVID, I think, because we're still trying to figure out why it happens, right?
Absolutely. Yeah. It's a complex issue for sure.
So this study, it's like it sheds some light, at least I think so, on what might be going on.
At the cellular level.
Yeah, exactly. Like what's happening with these T cells in people with long COVID?
Yeah, so they were really interested in seeing how these T cells, especially the ones that target the virus responsible for COVID-19, how they were behaving over those 2 years.
Makes sense.
They wanted to know, like, are the immune systems of people with long COVID reacting differently compared to those who recovered fully?
Oh, that's such a good question.
Right.
Because that's something we really want to know.
Huh.
And they had people from all over for this, right?
Right. They had groups in both Australia and Hong Kong, which is amazing.
Wow.
And they experienced a variety of long COVID symptoms, which, that makes the study even more relevant to what people are experiencing around the world.
So it wasn't just like, oh, this one specific thing. These people had all sorts of different things going on.
Exactly, a diverse group of people.
So, okay, so they took blood samples over 2 years. That's a commitment to science right there.
Oh my gosh, yeah. I can't imagine going back that many times.
Talk about dedication.
Seriously.
But they weren't just looking at any T cells, were they?
No, they were zeroing in on a very specific type, central memory T cells.
Ooh, fancy. What are those?
Think of these as the elite units of your immune system.
The Navy SEALs of T cells.
Laughs, basically.
Yeah.
They're the ones trained to remember and respond to specific threats long after the initial encounter.
Oh, so these are the T cells with the really good memories.
Exactly.
Like they remember every trick the virus has up its sleeve.
Precisely. They stick around and keep an eye out, ready to mobilize if that virus ever dares to show its face again.
So they're like, all right, virus, we got your number.
Exactly. They don't mess around.
Okay, so they're looking for these memory T cells in people with long COVID. What did they find? Were those elite units still on the scene?
Here's where it gets really interesting. They found that even 2 years after their initial infection, people with long COVID still had strong, active central memory T cells that recognize the virus.
2 years later. So even after all that time, their bodies were still ready to fight it off like, nope, not today.
That's what the research suggests, yeah. Their immune systems were remembering and responding. Those T cells were doing their job, even years down the line.
That's actually kind of reassuring, right? Like their bodies were still in the fight.
Right. It's a good sign.
Yeah. But I'm guessing there's more to this story.
Of course. The researchers didn't stop there. They also wanted to see if getting vaccinated impacted those T cell levels.
Oh, interesting. So even if someone already had long COVID, getting vaccinated could still make a difference.
That seems to be the case, yeah. They found that getting vaccinated boosted the activity of those central memory T cells in people with long COVID.
Wow. So even if you've been through long COVID, getting vaccinated could give your immune system an extra edge.
That's exact.
That's huge. Did the study say anything about why that might be?
Well, it doesn't give us a definitive why, but it's likely that the vaccine acts like a reinforcement training for those T cells.
Okay.
It's like reminding them, hey, remember this virus? Yeah, you do. Be ready for it.
Like a little reminder course.
Exactly, a little refresher course.
So vaccination as a refresher course for your immune system, even with long COVID.
Yeah.
That's interesting. So what about the people who recovered fully from COVID-19? Did their T cells look any different?
That's a great question. And it's one the researchers investigated.
Of course they did.
They compared the T cells of those with long COVID to those who recovered fully.
Okay.
And interestingly, the way the T cells were responding look very similar between the two groups.
So no matter how COVID-19 affected you initially, your T cells were just like, yeah, we got this.
Exactly. Like, this is old news. We know this guy.
Right.
However, there was one subtle difference that they found.
Okay. There's always a plot twist in these studies. What was it?
They found that people with long COVID had a slightly higher proportion of a specific type of T cell,
Okay.
one that's typically associated with fighting chronic long-term infections.
So does that mean that people with long COVID are stuck in a constant battle with the virus even years later? Like their bodies are just constantly fighting?
Not necessarily.
Mm-hmm.
This doesn't automatically mean that their bodies were actively fighting the virus at that moment.
Okay.
It's more like their immune systems were in a slightly different mode, you could say, than those who recovered fully.
A different mode. What do you mean by that?
Think of it like this. Your immune system is like a home security system.
Okay.
In people who recovered fully, it's like their alarm has been switched off and everything is back to normal.
Right.
But for those with long COVID, it's like their alarm, while not blaring, is still armed. It's in a heightened state of alert, which could be a factor in some of their symptoms.
That makes sense. Like it's just on high alert all the time.
Exactly. A little extra vigilant.
So their immune systems are still on guard duty, even if there's not an immediate threat.
Precisely. Which is fascinating.
Right. That's really interesting. So their immune systems are still kind of on edge, even though, like you said, the virus might not be a problem anymore.
Exactly. It's like they're prepared for round 2, even if round 2 never comes.
And that's what makes this research so fascinating, don't you think? It's like we're finally starting to uncover the why behind long COVID.
Absolutely. This study gives us a much clearer picture of what might be happening in the bodies of people with long COVID.
It's like we're finally shining a light on this thing, you know? Instead of just saying, oh, long COVID, it's a mystery, we're actually getting somewhere.
Yeah, we're getting down to the nitty-gritty, the cellular level.
Exactly. And what we're seeing is promising, right? Because those T cells, those elite units, they're still there, ready to fight.
Absolutely. They haven't given up, which is a fantastic sign.
They're like, we're here, we're ready, bring it on.
Yeah.
Laughs. Exactly. And on top of that, we're seeing how getting vaccinated can actually give those T cells a boost.
Which is huge. Because for a while there was this question of like, if you've already had COVID, does the vaccine even matter? But this seems to say that, yeah, it really does.
It does. It reinforces those memories, reminds the T cells what they're up against.
Right, exactly. But you mentioned something earlier about this all being a bit of a head-scratcher, too.
Oh, right. Yes.
What did you mean by that? What's got you puzzled?
It's those subtle differences in the T cell profiles, the ones we talked about earlier, with those chronic infection fighter T cells.
Right, the ones that are usually associated with, like, long-term infections.
Exactly. And the fact that people with long COVID have more of them, even when the virus isn't actively causing problems, it suggests that their immune system is operating a bit differently.
So it's not just that their bodies are fighting the virus the same way, but for a longer time, it's like their immune system is playing a different game entirely. That's a great way to put it. It's a different strategy, and that's what we need to figure out. Why? Why is their immune system reacting this way? What's causing that shift?
It's like their immune systems are stuck in overdrive, even when they don't need to be.
Exactly. And that's where the next phase of research needs to focus, I think.
Figuring out how to, like, hit the reset button.
Exactly. Imagine if we could recalibrate the immune response so it's not stuck in that heightened state of alert.
That would be incredible, because then you're not just treating the symptoms of long COVID, you're addressing the root cause.
Exactly. And this study, it gives researchers a roadmap, a starting point, to develop treatments specifically designed to do just that.
Wow. So this is really just the beginning, isn't it? This whole field of long COVID research, it feels like we're on the verge of some major breakthroughs.
I think so too. And it's exciting. The more we understand about how the immune system is responding in long COVID, the closer we get to developing effective treatments.
Well, I, for one, am very excited to see what they discover next. This has been an incredibly eye-opening deep dive into long COVID and T-cell research.
It really has.
And to our listeners, if you want to check out the full PNAS study we talked about today, you can find a link in our show notes.
Please do.
Until next time, stay curious, everyone.